Hey, good morning everyone. So this is a seventh lecture of geometry algorithm playlist. So today we will be going to see the interesting question. I know in every video I will say this is an interesting question, this is an interesting question, but this question is literally very interesting question is. So what is the question? So we have given a array, okay, and we have to find the minimum cut required to divide the circle into equal parts. So given an array, let's say ARR, which represent a different angle at which a circle is cut, and the task is to determine the minimum number of more cuts required so that the circle is divided into equal parts. And here one thing is also given, so the array is unsorted in ascending order. Okay, so how can we solve this question? So let's do some conceptual thing. Okay, some conceptual parts. After that we will do coding. Okay, so we have given an array. This is an array. The array, I have already told you that the array represents the different angle at which a circle is cut. We need to find the number of more cuts required so that the circle is divided into equal parts. So here this array 0, this 0 degree is 90 and 180, and this is 270 degree. Okay, so these 4 cuts is already given. Okay, so how many more cuts required so that we can divide this circle into equal parts? Use brain. So here we can see the 0, 90, and the 90, 180, and 180, 270, and 270, 0. The 4 parts is already in equal parts. This is also 90 degree. This is also 90 degree. This is also 90 degree. If the radius, let's say this radius of this is r, so we know that the 1/4 of this part, this is a 1/4 of the whole circle. This is also a 1/4 of the whole circle, and same with this, same with this. So this is already in equal parts. So how many more number required, or how many more cuts required to? So there is only 0 cuts required. Okay, so 0 number of cuts required so that the circle divided in equal parts. This is example 1, and let's example 2 also. So this arrays have given 90 and 210. So let's take this circle. Okay, similarly I will just divide this is 4 parts, so we can easily observe how many more cuts required. So we have given 90 and 210. Yeah, so these two different angles at which the circle is cut is 90. Okay, so this is a 90 degree, this is a 90 degree. Okay, and the second is 210. So 210 will be, let's say, here in between 180 and 270, somewhere this 210 degree will be come. Okay, so there are 2 cuts we have given, and we have to find how many more cuts required to divide this circle into equal parts. Okay, so we can easily see this circle is not in equal parts. So how many cuts? So let's say, what is the difference between 210 and 90? So this difference is, what is the difference? See, So the difference is 120. Okay, so if we add 120 more, like 120 more in 200, so this will be 330. 330 from this 330, and this, if we 330 add to 120 more, then this will be 90. Okay, or we can say, so we can easily see, so one more cut is required to divide the circle into equal parts. So 3 equal parts. So what is the output of this course? This is 1, and what the output of this array is 0. I hope you have understand the questions. So let's come into the approach that we use in coding part. So I have written already the approach. So the approach is, the idea is to calculate the first we have to calculate the greatest common divisor, GCD, of all values, often with the consecutive difference of 2 elements in the array, in order to find greatest possible size for the part the circle can divide into. So we need to find, first let's take one variable, is like any variable, we can say temp. This is very convenient for me, so let's temp. Okay, first what we have to do, first find difference between this array of 1 and array of 0. Let's say array of 1 and minus array of 0. So store this value in temp. Now this is the first step. Now second step is just store, the next step is to do temp equal to GCD, the greatest common integer, greatest common divisor of this temp and comma difference between array of I minus array of I minus 1. Okay, so I will repeat it. So what we will be going to do, first store the absolute difference of first 2 value of the array in variable named factor. Here I have taken a factor, you can take anything, you can take. Okay, this is a let's say factor. Okay, and what I have done, first store the value array of 1 minus array of 0 in factor. After that, now traverse the array from index 2 to n minus 1, and for every elements update the factor as a factor equal to GCD of factor comma array of I minus array of I minus 1. Okay, and now now the last value of elements update the factor GCD. This is a GCD of factor comma 360 minus array of n minus 1 plus array of 0. The last what element is left, the last this array of this. So we first find the difference and store the value in factor, then after that update the factor by the difference of the factor GCD of factor comma difference between these two, and then third step again update the value of factor equal to GCD of previous value of factor comma 360 minus difference between these two, array of n minus 1 minus array of 0. Same thing I have written here. So 360 minus array of n minus 1 and plus, if we take in bracket, then it will be array of n minus 1 minus array of a0, and then after opening this bracket, so this minus minus will be plus. So same thing. So 360 minus array of n minus 1, and this is, and then finally we found the total cuts required will be 360 by factor minus 1, and the time complexity of this whole algorithm will take big O of n comma n multiply log of minimum a comma b. A and b is a variable, like this is this variable, like array of a I minus array of n minus 1. This is the time complexity of GCD, I think, and for we will be traverse the whole array n, so n into log of minimum of a comma b. So let's come into the coding part. So I have already written the code. So for this is a function for GCD, finding GCD of any number. So this is a easy, you can see the main thing is here. So for same approach I have used. What I have done, we have given an array and the n. So first I have find the difference between array of 1 and array of 0, and then I treat the value I equal to 2 to whole size of array, and update the factor by GCD of factor comma array of I minus array of I minus 1. And third step is that factor update the factor equal to GCD of factor comma 360 minus array of n minus 1 plus array of 0. And now this is finally we have to find the minimum number of cuts, so that is equal to 360 by factor minus n, and return the 360. Okay, now I have taken the same example that I have taken here also. The same example I have taken. This is 0, 90, 130, 180 and 270. So let's run this code. So you can see the value is 0. Let's do one more, is 2, 1, 0. I have taken this, sorry, 90 and 210. Okay, take 90 and 210. Yeah, you can see easily the minimum number of cut is required is 1. So similarly you can use lots of examples here. So this is the code, and that's it for this video. Thank you so much for watching this video. Thank you.